So as we saw from the previous course, most contact lens fitting now, for gas panels certainly, is done empirically. So what we thought we'd do is give you an example of an empirical fit, so you can work through the numbers and see exactly how we arrive at the lens specifications. So let's take this example. As we stated previously, we need the spectacle prescription adjusted for BVD if it's over ±4 in any meridian. So a patient who's got a spec Rx of -2, -3 at 15 would still need a BVD because we're over 4 in one meridian. We need to take good keratometry readings. Now, if our patient's been in a dry atmosphere or if our own consulting rooms are highly air conditioned, you may find that the tear quality is quite poor, which will give us poor keratometry readings. So sometimes some comfort drops inserted just before keratometry can help us get a good, accurate, sharp reading for our patients. Horizontal visible iris diameter measured as accurately as possible. And we also need to think about what type of design we want, whether we want to use a quasar aspheric, an icon spherical multicurve, etc. And finally, what material we want the lenses made out of. So Optimum Extra or Boston XO or ML92 material. All of these will have their own different set of properties, which we should consider when thinking about a gaspanable lens. So let's take this example of our keratometry, HVID, spectacle prescription, palpebral aperture and BVD. And if we look at this as an example, say we have a patient who has keratometry of 7.8 by 7.6, so they've got with the rule astigmatism, got an HVID of about 11.5 millimeters. The spectacle prescription is -2, -1 at 180. They've got a nice average 9.5 millimeter palpebral aperture. And BVD in this instance, because it's under 4, is not necessary. Now, if we think about what lenses we would use, we take the flattest keratometry reading, which gives us a BOZR of 7.8 millimeters. We subtract 1.5 millimeters approximately from the HVID, so that gives us a total diameter of 10 millimeters. Because it's only a diopter of corneal sill and it aligns with the spectacle sill, no toric lens is needed. So the prescription of the lens is a -2. All very straightforward, very simple. So if we decided that we was going to choose a quasar lens, that will give us a 7.8 BOZR, 10 diameter, -2 BVP. If we look at another example, this patient has a spectacle Rx of -3, -1 at 180. The keratometry readings are 7.7 by 7.5. HVID again 11.5. We're going to choose a spherical multicurve or an aspheric for this patient, and which material. So looking at our example, the final lens specification, the power of the lens will be -3 because the cylinder is under 2.5 diopters and matches the corneal sill, so no toric is needed. We've taken the flattest keratometry reading of 7.7 to calculate our back optic zone radius. And using our horizontal visible iris diameter of 11.5, it gives us a total lens diameter of 10 millimeters. We chose the quasar design because it is a lens design that a lot of patients find very comfortable, gives great vision. And finally, we chose Optimum Extra material. Now this material has a DK of 100, which ensures that we adequately oxygenate the cornea to prevent any kind of hypoxia, even with long wearing times. We specified a blue tint. Now this is a pure visibility tint, does nothing to the patient's eye colour. It's just to help them see the lens when it's in the case, particularly if they're highly ametropic. The Optimum Extra material is available in other colours, so again for high myope you could have grey in the right and blue in the left, just to aid the patient's identification of the lenses correctly for each eye. So to summarise, empirical fitting really is very easy. All we need you to do is send us the measurements of the patient's eyes and their prescription, and we will send you the lenses. Please don't be afraid to say to us, I don't know. We'll talk you through the process, describe what measurements we need to enable you to be able to produce a pair of lenses. Please don't think that there are any silly questions. Don't be embarrassed about asking questions. We are here to help, and we will not ridicule or mock you on slip. The first fit success rate with empirically fitted lenses is really very high, and you'll find that you'll often not need to make any adjustments to these lenses when you put them on the patient's eyes.